Hi, so welcome to the presentation of the final project. We are the Super Epic DB group, and this is our basketball play diagrammer. My name is Kieran Andrews.
I'm Christian Molina.
And I'm Thad Post.
So, starting off, we have our motivation and goals. So, this project is a play diagrammer for 3-on-3 basketball. It allows users to create, visualize, and share basketball plays. The tool provides several services, including play creation, where users can design custom plays by positioning players and drawing their movement paths. Visualization, the tool offers a clear and interactive way to visualize the plays. And then sharing, users can share their created plays with others easily. Now, who could find this useful? We have coaches to design and communicate strategies with their teams, players to better understand and execute plays, and then analysts to study and analyze different play strategies. This tool aims to enhance the strategic planning and execution of 3-on-3 basketball games. So for our entity relationship diagram, we have 7 entities, which include 2-point area, court, hoop, player indicator, ball, player, and team. You may notice that ball is all on its own, and that's because we don't really have a good reason to have it have a relationship with anything. As you'll see in a moment, uh, the ball only appears during passing plays and being when it is shot, and that's because we have a top-down view of the play, so the ball would be covered by the player, so it doesn't really make sense to have it. Moving on, let's cover the relationships. So we have the relationship between team and player. Player plays for a team. Every team will have multiple players, but player can only play for one team. And then we have players being represented by a player indicator. Every player indicator will have one player, and vice versa. And then we have court. Court has a 2-point area and a hoop. Since we're only working with half of the court, since that's these plays will only be for one half of a court, there is only one 2-point area and one hoop. Then for most of these, they have a X and Y coordinate, like court, 2-point area, hoop, player indicator, ball. That's just so we can see how they're positioned on the court. Uh, and then players have some additional attributes of height, name, weight, um, just for some additional information to query. And then teams have team names. So here are our derived tables. We have court, which has an ID, X and Y. 2-point area, which again has ID, X and Y. And then a new derived table, player indicator square, which is how we actually see the players and which are the things getting animated. They have ID, X, Y, and T. And then player indicator point, which will have the same ID, X, Y, and T, but this is used for queries and like getting the data for where a player is and what they're doing. Then we have ball, which has ID, X, Y, and T, hoop, which has ID, X, and Y, team with ID and name, and then player with ID, team ID, their name, their position, and not position like X, Y, but the position they play on the basketball court. And then height, weight, and their jersey number.
All right, for our data sources, we get all of our player information, their name, height, weight, jersey number, stuff like that, from basketballreference.com. It's basically a reference site where you can search up pretty much any NBA player and find information about them. For our court dimensions, you can go to the link there, the official NBA.com link, and there is a official diagram for the measurements of basketball courts and everything to do with that. As for the play design, which we'll show you in our animation later on, we made that ourselves in a way that sort of made sense. All right, so for team one, we have 3 players, LeBron James, Stephen Curry, and Anthony Davis. Some of the information that you can see is listed under them is things like nicknames, links to their social media stuff. The stuff that's relevant for us, though, is their positions and then their heights and weights, which are listed on the website in both metric and United States measurement units. And so we have the 6'9", 250 pounds LeBron James. What we do is we take the 6'9" and convert that to inches. So that would be 81 inches, I believe. Yeah, 81 inches. And then same stuff for Stephen Curry, Anthony Davis. So that's team one. And then on team two, we have Kevin Durant, Kyrie Irving, and James Harden. There's also their teams. So here you can see Kevin Durant plays for the Phoenix Suns, Kyrie Irving plays for the Dallas Mavericks, and James Harden plays for the Los Angeles Clippers. And then for our court, what we did is we took i2v2c.m, the matplot or the MATLAB function, to map out both the court and the 2-point area. So on the left, you can see we have a rectangle mapped out in lime green for the half court dimension. And then on the right, we have the 2-point area mapped out in sort of a semicircle arc. And then we imported that into MLPQ.
So this is the play that Thad was talking about that we devised ourselves. So here we can see that we have the 6 players and they are bunched up in groups of 2. So we have a player for one team matched up against a player on the other team. We don't have 2 players guarding one person because that would just leave another person wide open, and that's obviously not good in 3-on-3. So what we have is that we have a player from, let's call it team A, starts with the ball, and they're going to call for their teammate to come set a screen so they can get around their defender. But that person who just got the screen called for, their defender is obviously going to follow them because they don't want to just stand there doing nothing. And when the player with the ball tries to go around the screen, they run right into the defender. So they go and they pass it out to the third player on their team, who moves forward into the 2-point to receive the pass. Their defender follows, but then the person who just received the ball steps back into the 3-point land and shoots the ball. So, alongside the animation, we had a lot of fun doing that. We also came up with a few functions to help find out some interesting information. So, for example, the first function we devised was to find all the players who are in the 2-point area at some time period t. So, in this instance, we devised a basic SQL query, literally basic SQL, and what we selected was we wanted to know the player's ID, as well as their X and Y coordinates, and what time it was, just for verification purposes. So we selected from the player indicator point instead of the player indicator square, and the reason we did that was because the point, we could tell exactly, is this very specific point like X 1237.5, Y 3087.5. Is that exactly within the 2-point area? And that is much easier as opposed to trying to do it with the squares because, for example, if you look at this player right here, he is somewhat within the 2-point range, somewhat outside the 2-point range. But if you look at the dot that represents the player indicator point, you can trace out the 2-point line and you can see that this player is technically outside. But if you actually do your counting, you can see 1, 2, 3, 4 players are inside the 2-point area at time t20. And if we look, those are players 1, 2, 4, and 5. And we can see their associated X and Y values. Now, you see these PX and PYs. So that indicates that the player is in motion at that time. So player 2 and player 5 and player 4, excuse me, are in motion. So you would have to scroll over to see the constraint to find out where the actual X and Y position is, but we just wanted to show you the results, I guess. Next, we have the second function we came up with, and this is to find where a player is at some time. So let's say we want to find Kyrie Irving. So Kyrie Irving is given the player ID of 6. So we created a basic SQL query again, and we just said, all right, we want to find out where player ID 6 is at player time 30. And we just selected the ID, X, Y, and again, T for validation purposes. So since Kyrie Irving is not moving at time T30, we get the exact results back of he's at 1057.5, 3227.5. And finally, alongside doing things with location and whether a player is inside or outside the 2-point area, we also came up with a function that we thought was pretty interesting of finding the average height by position. Because for some positions, we have multiple players, and some players are the only player at that position. So this was a nice, interesting query. So this was an aggregation query instead of just a SQL basic. And we just selected P dot position and the average of P dot height, and we grouped it by the position. So we can see that the players that are listed as power forward, which is just Anthony Davis, he is 82 inches tall, so it just goes back 82. But there are 2 players who play point guard in the player database, so it averaged out their heights to be 74.5 inches, and the same goes for small forwards as they are 81.5 inches. Now, shooting guard, again, there's a lonely player, and that is Kyrie Irving. So he just gets his height listed as 77 inches.
So finally, we have our conclusions and future work. So for our conclusions, we found that it's possible to make a representation of a basketball game in MLPQ, that simple queries can provide a lot of information quickly, and that many real-world scenarios can be represented with SQL tables and relations. Now, for some future work, we could get real data from games, incorporate statistics for players like shot probability and other player metrics, and then allow more team types such as 5v5, 4v4, etc. And then lastly, we could add relations for more present plays. For example, a pick and roll, a 3-point shot, things like that. Thank you for watching.